Hi everyone. Today we are going to discuss one of the important topic of differential calculus, that is successive differentiation. So in this chapter, what we do, if we have a function y is equal to f of x, then we find that differentiation of y with respect to x, that is y dy upon dx. So we differentiate this one time dy upon dx, that is equal to f dash x. So we also denote this dy upon dx, first derivative of y with respect to x, by y1. So if we again differentiate this, then the second derivative is y2, and that is equal to dy dx of dy upon dx, and that is same as d2y over dx2, and this is equal to f double dash x. Now if we again differentiate y2 with respect to x, then we get y3. This is the third derivative of y with respect to x. So this is dy dx of d2y over dx2, and that is d3y dqy upon dx2. It is equal to f3 time derivative f3 dash x. Next is, if we again differentiate, then we get y4. y4 is, we get d4y over dx4, and that is same as f4 time derivative at point x. Similarly, so if we differentiate n time, then we get yn, that is equal to dny over dxn, that is same as f nth derivative at point x. So in dy upon dx, this y is dependent variable, and this x is independent variable. So let us discuss one example. So if we have y is equal to x square e to the power x, and we have to find the third derivative. Find third derivative of y with respect to x. Then, so what we do, we find y1. y1 is one time differentiation of y with respect to x. So that is dy dx of y, the same as dy dx of d upon dx of y. So it is equal, this is equal to d upon dx of, what is y? X square into e to the power x. So we can use the product rule, and that is equal to x square, derivative of e to the power x is e to the power x, plus derivative of x square is 2x into e to the power x. So this is the first differentiation, first derivative of y with respect to x. So this is y1. Now y2, again we differentiate this, that is dy dx of dy over dx. And what is dy over dx? That is dy dx of x square e to the power x plus 2x e to the power x. We can simplify this. instead of writing this, we can also write this as x square plus 2x into e power x. We can take e power x to be common. So here x square plus 2x into e power x. Now again we use the product rule. So we can write x square plus 2x e power x, derivative of e power x is e power x plus x square plus 2x, derivative of this is 2x plus 2 into e power x. So again we can take e power x common. So we get x square plus 2x it is 4x plus 2 into e power x. Okay. So now we again differentiate. We find y3, and y3 is equal to d by dx of d2y over dx square. That is equal to d upon dx of, what is d2y over dx square? This is y2. So x square plus 4x plus 2 e to power x. Again we use a product rule. So first function x square plus 4x plus 2, derivative of e to power x is e to power x plus derivative of x square plus 4x plus 2, that is 2x plus 4 into e to power x. So again we can take e to power x common. So it is x square plus 4x plus 2x, it becomes 6x plus 4 plus 2, it is 6 e to power x. So in this way we can find the derivative of x square into e to power x 3 times. So this is a third derivative. Therefore, y3 is equal to this. So we can find the third derivative of y with respect to x, that is y equal to x square e to power x. So third derivative of y is x square plus 6x plus 6 e to power x. So now let us come to some examples, some questions. Let us discuss question number 1. If y is equal to e to power x sin x, we have to show that its double derivative is 2 into e to power x cos x. So y is e to power x sin x. So let us start. Given y is equal to e to power x into sin x. So this is y. So we have to find that its double derivative. So let us find first derivative y1. Y1 means differentiate y with respect to x. We get y1 is equal to d by dx of y. And what is y? D by dx of e to power x sin x. So you use the product rule, we get e to power x, derivative of sin x is cos x, plus derivative of e to power x is e to power x into sin x. So we can write y1 is equal to e to power x cos x, plus we can also write this as y, because e to power x sin x is again it is y. Y, if this is our first equation, so y using 1. Now again differentiate with respect to x, we get y2. Now what is the derivative of this? Again we use the product rule here. So it is e to power x. Derivative of cos x is minus sin x, plus derivative of e to power x is e to power x cos x, plus derivative of y is y1. Right? So y2 is equal to minus e to power x sin x plus e to the power x cos x plus y1. And what is y1? Y1 is e to the power x cos x plus e to the power x sin x. And so this is cancel out. So we get y2 that is equal to 2 e to the power x cos x. So hence we get the required answer. Okay. So now on to second. If we do first we do question number 3. Find the fourth derivative of x cube log x. Find the fourth derivative of x cube log x. So this is question solution of third part. So let y is equal to x cube log x. We have to find the third derivative of this y. So let us find first derivative of y. Y1. Y1 is dy dx of y. We have to differentiate y with respect to x. That is d upon dx of what is y? X cube log x. So we use product rule. We can take x cube be first function, log x be second function. So x cube derivative of log x is 1 upon x plus derivative of x cube is 3x square log x as it is. So x and x cancel out. So this is equal to x square plus 3x square log x. So this is y1. Again differentiate both sides with respect to x. We get y2. Y2 is dy dx of y1 and y1 is dy upon dx. And that is dy dx of x square plus 3x square log x. So derivative of x square is 2x plus again we use product rule here. So this is our first function. This is our second function. So we can write 6x log x, or because derivative of first into second, first derivative of second plus second derivative of first. So now we find the derivative of log x. So 3x square into log x. Derivative of log x is 1 upon x. So x and x this cancel out. So we get 3x. So 2x plus this 3x, it becomes 5x plus 6x log x. So this is our y2. Now y3. Y3 again differentiate this with respect to x. We get derivative of 5x is 5 plus 6x log x. It is 6x. Derivative of log x is 1 upon x plus 6 log x. X and x cancel out. So we get 6 plus 5 is 11 plus 6 log x. So this is y3. Now again differentiate. So y4. Y4 is derivative of 11. 11 is constant, so its derivative is 0 plus 6. Derivative of log x is 1 upon x. So we get 6 upon x. So this is the fourth derivative of y. So even we can write y4x. So this is y4x. That is equal to 6 upon x. Fourth derivative of y with respect to x, that is equal to 6 upon x. So these results are very simple. You have to differentiate one by one. If we have to find the fourth derivative, so can you tell me what is the fifth derivative of this? If we again differentiate, then the derivative of 1 upon x is minus 1 upon x square. So it becomes minus 6 upon x square. So you can differentiate this up to many times. If we have to find the 10th derivative, then you continuously you have to differentiate up to 10 times. Okay. Now come to question number 2. If under root x plus under root y equal to under root a, then we have to find the double derivative at x equal to a. So what is given? Under root x plus under root y equal to under root a. So this is given. Let this be equation 1. So differentiate both sides with respect to x. Even you can try this question by two methods. First, you have to differentiate both sides with respect to x. This is one method. Or second is you shift under root x to the right hand side. We get under root y equal to under root a minus under root x. And then squaring both sides, we find y. Then you differentiate one by one. Right? So there are two methods. So you can try by using by converting this into, so under root y equal to under root a minus under root x, squaring both sides, so we get y equal to under root a minus under root x whole square, that is equal to a plus x minus 2 under root a under root x. So you get y. So you try by using this. I skip this part for the viewers to solve this equation, or find the differentiation, second order differentiation of y with respect to x by using this. Now again, in second method, how we can solve this? Differentiate both sides. Differentiate equation 1, both sides with respect to x. We get, so d by dx of under root x plus under root y is equal to d by dx of under root a. So we know that it is linear, so we can write d by dx of under root x plus under root y as d by dx of under root x plus d by dx of under root y. That is, derivative of constant is 0. A is constant, so derivative of constant with respect to x is 0. This implies. So this implies 1 upon 2, derivative of this is 1 upon 2 under root x plus 1 upon 2 under root y dy upon dx, that is equal to 0. So this implies 1 upon 2 under root y dy upon dx, that is minus 1 upon 2 under root x. So 1 upon 2 cancel out, so we get, this implies dy over dx is equal to minus under root y over under root x. So this is our y1. Again differentiate, let this be equation 2. Again differentiate equation 2. Equation 2, both sides with respect to x, we get d2y over dx square equal to dy dx of minus under root y over under root x. So now we can use derivative of u upon v. So that is minus, you can take minus common. Second function, that is under root x. Derivative of under root y is 1 upon 2 under root y dy upon dx minus under root y. Derivative of under root x is 1 upon 2 under root x. Bracket close, whole divided by under root x ka whole square. So this is equal to minus, this is double derivative d2y over dx square. This implies minus, what is dy upon dx? Now by using equation number 2, we get what we get, dy upon dx equal to minus under root y upon under root x. We can put the value of dy upon dx here. Under root x upon 2 under root y into dy upon dx is minus under root y over under root x. Minus under root y over 2 under root x divided by x. So under root y and under root y cancel out, under root x and under root x cancel out. And even we can take the, here it is minus sign. So we can write this as minus 1 by 2 minus under root y upon 2 under root x whole divided by x. This is equal to, you can take minus 1 by 2 common. So minus already bahar hai, so it become 1 upon 2 and this is 1 plus under root y over under root x whole divided by x. So we can also write this as, this is equal to 1 upon 2x. You can take under root x LCM. So under root x plus under root y over under root x. Now, since under root x plus under root y in equation 1, it is given that this is equal to under root a. So we can put the value. So we get 1 upon 2x under root x into under root a. So this is the 2-time derivative of y with respect to x. Now we have to find d2y over dx square at x is equal to a. So we put x is equal to a. So we get 2a under root a under root a. So it is cancelled out. We get 1 upon 2. So in this way, you can find the double derivative of y with respect to x at point x equal to. So now the next question is, if y is equal to, this is question number 4. If y is equal to sine m sine inverse x, so we have to prove that 1 minus x square by 2 minus x by 1 plus m square y equal to 0. So what is given? Y equal to sine m sine inverse x. So we write y is given, y is equal to sine m sine inverse x is equal. So what is y1? What is y1? The derivative of sine is cos m sine inverse x, and then again we differentiate m sine inverse x. So we have to derivate m sine inverse x with respect to x, and this is equal to cos m sine inverse x into the derivative of, you can take m to be common, and derivative of sine inverse x is 1 upon under root 1 minus x square. So this is y1. So if we cross multiply, or we can write y1 as m cos m sin inverse x whole divided by under root 1 minus x square. Or we can write this as this implies. Or we can write under root 1 minus x square y1 that is equal to m cos of m sin inverse x. Now let this be equation number 1. Let this be equation number 1 and this be equation number 2. Now we differentiate, again differentiate, again differentiate equation 2 both sides with respect to x we get. So in left hand side we apply the product rule. So under root 1 minus x square, this is first function, and derivative of y1 it is y2 plus under root 1 minus x square. What is the derivative of this? It is 1 upon 2 under root 1 minus x square, and again 1 minus x square का derivative क्या होगा? It is minus 2x into y1. That is m. What is the derivative of cos? It is minus sine m sine inverse x, and m sine inverse x derivative of this, that is m upon under root 1 minus x square. So 2 and 2 cancel out. So under root 1 minus x square y2 plus, so it is minus x upon under root 1 minus x square y1 is equal to minus m square and sine m sine inverse x. So it is given y is equal to sine m sine inverse x. So we can write, instead of, in place of sine m sine inverse x, we can write y over under root 1 minus x square. So this implies. So taking left hand side under root 1 minus x square as LCM in left hand side, so we get 1 minus x square into under root 1 minus x square into under root 1 minus x square, that is 1 minus x square under root 1 minus x square whole square. So it is 1 minus x square y2 minus x y1 over under root 1 minus x square equal to minus m square y over under root 1 minus x square. So this is cancel out. Then cancel this. We get 1 minus x square y2 minus x y1 plus m square y, that is equal to 0. Hence the proof. So we have to prove this. 1 minus x square y2 minus x y1 plus m square y, this is equal to 0. Let us come to example question number 5. Y is equal to log x plus under root x square plus 1. So we have to prove that x square plus 1 d2y over dx2 plus x dy upon dx equal to 0. So what is given? Y equal to log x plus under root x square plus 1. So y is equal to solution of 5. Y is equal to log of x plus under root x square plus 1. So this is the given y. So now we have to find the first derivative. So let us find y1. What is y1? The derivative of log x is 1 upon x. It is 1 upon x plus under root x square plus 1 This is the derivative of log x. Now we have to again differentiate x plus under root x square plus 1. What is the derivative of x plus under root x square plus 1? And this is equal to 1 upon x plus under root square plus 1 into derivative of x is 1 plus derivative of under root x square plus 1 is 1 upon 2 under root x square plus 1, and again differentiate x square plus 1, we get 2x. 2 and 2 cancel out. So we get, this implies y1 is equal to, we get 1 upon x plus under root x square plus 1 into, you can take under root x square plus 1 as LCM, and this is under root x square plus 1 plus x. So this is same, x plus under root x square plus 1 of x plus under root x square plus 1. So we can cancel this. So we get y1 is equal to 1 upon under root x square plus 1. Or we can also write this as x square plus 1 की power minus 1 by 2. So this is our y1. Now we find y2. Now we find y2. Again differentiate y1 with respect to x. We get y2, that is minus 1 by 2 x square plus 1 to power minus 1 by 2 minus 1, that is minus 3 by 2. And then again derivative of x square plus 1 is 2x. 2 and 2 cancel out. So we get minus x upon x square plus 1 to power 3 by 2. So this is y2. So now what you have to do, you have to prove that x square plus 1 into d2y over dx2 plus x dy upon dx equal to 0. So we have find y2. So now from left hand side, now we have to prove that x square plus 1 y2 plus x y1, that is equal to 0. So let us solve this. So x square plus 1, what is y2? This is minus x upon x square plus 1 to power 3 by 2 plus x into y1. y1 is 1 upon under root x square plus 1. So x square plus 1 and x square plus 1 to power 3 by 2. When we cancel this, it become under root x square plus 1 plus x upon under root x square plus 1. So that is equal to 0. So we get the result. Right? So you can prove this by finding the value of y1 and y2, and then what we have to prove. So we try to put the values in the left hand side, and then we get right hand side. This is the one way. The second way that when we find y1 here, when we find y1, so after this, what we do, so this is the alternate. Either you prove by this method or this is the alternate. You multiply it by under root x square plus 1 both side, or cross multiply under root x square plus 1, we get under root x square plus 1 y1 equal to 1. Now we have to find the double derivative. So again differentiate this with respect to x. So we get under root x square plus 1, derivative of y1 is y2, plus derivative of under root x square plus 1 is 1 upon 2 under root x square plus 1 into again 2x plus 1 का डेरिवेटिव 0 हो गया, तो 2x plus 0 is 2x into y1, that is equal to derivative of 1 is 0. So 2 and 2 cancel out. So this implies we get under root x square plus 1 y2 plus x upon under root x square plus 1 y1 equal to 0. So cross multiply taking x under root x square plus 1 as LCM. So we get x square plus 1 y2 plus xy1 and under root x square plus 1 into 0, that is equal to 0. So we get the result. So this is simpler. Second method is simpler than the previous one. So you try to prove these results by using this approach. Okay, so now come to next question. Next is y is equal to tan inverse x whole square, and we have to prove that x square plus 1 whole square y2 plus 2x x square plus 1 y1 equal to 2. So y equal to tan inverse x whole square. So we start with this. Y is equal to tan inverse x whole square. So differentiate both sides with respect to x, we get y1, that is 2 tan inverse x, and then derivative of tan inverse x is 1 upon 1 plus x square. So what we do, we try to use the approach that cross multiply by 1 by x square both sides. So 1 plus x square into y1. By using this approach, the question becomes simpler. Rather than if we differentiate, we can use quotient rule, but it becomes difficult as compared to this one. So this is 2 tan inverse x. So now again differentiate this above equation both sides with respect to x, we get 1 plus x square, derivative of y1 is y2 plus 1 plus x square का derivative हो गया 2x, y1 that is equal to 2, tan inverse x का derivative हो गया 1 upon 1 plus x square. So again cross multiply by 1 plus x square, we get 1 plus x square whole square y2 plus 2x 1 plus x square y1 that is equal to 2. So this is the required. We have to prove this. So this is x square plus 1 whole square y2 plus 2x x square plus 1 y1 equal to 2. So hence we get the result. So I hope you can try this part. Y equal to sin inverse x का whole square. This is same as question number 8 is similar as question number 6. So y equal to, now I, and question number 7 is similar to, question number 7 is, okay. So let us discuss question number 7 and then we discuss question number 9. Question number 8 is, you try this. So question number 7, y equal to cos inverse x. We have to prove that 1 minus x square y2 minus x y1 equal to 0. So solution of 7, y is equal to cos inverse x. So what is y1? Minus 1 upon under root 1 minus x square. So cross multiply 1 minus x square into y1, that is equal to -1. So this implies, now again differentiate. So we get under root 1 minus x square, derivative of y1 is y2, plus 1 upon 2 under root 1 minus x square, and derivative of 1 minus x square is minus 2x, y1, that is equal to 0. So this implies 2 and 2 cancel out. So under root 1 minus x square, y2 minus x upon under root 1 minus x square, y1, that is equal to 0. So taking LCM, so we get 1 minus x square, y2 minus xy1 upon under root 1 minus x square equal to 0. So when we multiply it by 0, we get this. So this is the result. Hence the result. Right? So we have to approve this. Now come to ninth question. Y equal to e to power tan inverse x, and prove that 1 plus x square y2 plus 2x minus 1 y1 equal to 0. So y equal to e to power tan inverse x. Y is equal to e to power tan inverse x. So what is y1? Differentiate both sides with respect to x. We get y1 is equal to e to power x is e to power x. So e to power tan inverse x. Again we differentiate tan inverse x with respect to x. So we get 1 upon 1 plus x square. So what is my next step? Can you tell me? Yes. So we multiply by 1 by x, 1 plus x square. To the left hand side, we get 1 plus x square y1 equal to e to power tan inverse x. Even e to power tan inverse x is y. So instead of, or we can differentiate again by using the same. So again differentiate, or you can also write this 1 plus x square into y1, that is equal to y, because y is equal to 10 e to the power 10 inverse x. So we can write, instead, in place of e to the power 10 inverse x, we can write y. Now again differentiate. Again differentiate both sides with respect to x. We get, so 1 plus x square, derivative of y1 is y2, plus 1 plus x square का derivative 2x, y1 equal to derivative of y is y1. So this implies 1 plus x square y2 plus 2x y1 minus y1, that is equal to 0. So this implies 1 plus x square into y2 plus 2x minus 1 y1, that is equal to 0. So this is the required result. So hence the result. So in this way, so today what we do, we have discussed a lot of examples related to successive differentiation. So you try question number 8 and some more examples related to this topic. We will meet in the next video lecture with a new topic. So thank you. Have a nice day.